The James Webb Space Telescope, a true titan in the world of astronomy and a marvel of modern engineering, has recently gifted us with an amazing, utterly captivating image of Saturn, our solar system's celebrated ring jewel. This extraordinary picture goes far beyond our wildest dreams, presenting Saturn's ethereal rings in a strikingly new and intensely luminous light. With this monumental achievement, Webb has now completed its photographic tour of our solar system's giant planets, successfully capturing its inaugural images of all four gas giants: the majestic Jupiter, the enigmatic Saturn, the mysterious Uranus, and the distant Neptune. But in stark contrast to the familiar, often striking pictures taken by the Hubble Space Telescope, where Saturn is frequently depicted with vibrant, bright bands of swirling clouds, this groundbreaking new image from Webb paints an entirely different, almost otherworldly picture. Here, Saturn appears as a strangely dark, somber circle, mysteriously colored in muted shades of warm orange and deep brown, an appearance that is quite unusual and immediately prompts the question, why is it so different? The profound answer lies in the specialized, invisible wavelengths of light that Webb masterfully employs to observe these distant celestial objects. Unlike the famous Hubble telescope, which operates primarily in the visible light spectrum, much like our own eyes, the revolutionary Webb telescope utilizes infrared light to peer into the universe. While we cannot perceive infrared light with our naked eyes, its utility is vast and profound. For instance, it provides an invaluable tool for understanding heat or thermal emission. Therefore, if we endeavor to learn about the intricate processes unfolding on a planet perpetually shrouded in thick, opaque clouds, we can meticulously study its unique heat signatures, effectively seeing through the obscuring veils. In fact, the very same infrared light that allows Webb to unravel cosmic mysteries is a mundane yet essential part of our daily lives, used by your remote control to effortlessly change channels on your TV or precisely adjust your air conditioner. Moreover, infrared light possesses longer wavelengths than visible light, an optical property that grants it remarkable penetrative power. Because of this characteristic, it can effortlessly travel through vast expanses of thick gas and cosmic dust in space without getting unduly scattered or absorbed. This incredible ability means that Webb can reveal hidden objects and phenomena in space that remain entirely invisible to telescopes reliant solely on visible light, effectively pulling back the cosmic curtain on previously unseen wonders. Now, let's turn our attention specifically to Saturn and its intriguing appearance. When infrared light of a particular wavelength encounters the abundant methane gas in Saturn's atmosphere, almost all of that light is efficiently absorbed. This powerful absorption is precisely why Saturn looks so remarkably dark, almost like a silhouette, in the picture captured by Webb. Interestingly, even though the planet is currently nearing the conclusion of its extensive 7-year summer, a period typically associated with more sunlight and warmth, the northern part of Saturn appears even darker than scientists had initially expected, adding another layer to the cosmic mystery. Scientists are currently engaged in a diligent quest to decipher the reasons behind this unexpected darkness. One prevailing theory suggests it might be due to some as yet unknown atmospheric process occurring within Saturn's upper layers, leading to the creation of tiny, suspended particles, commonly referred to as aerosols. On the other hand, the atmosphere hugging the very edges of the planet's disk, the limb, shines with a surprising brightness, creating a luminous halo. This captivating luminescence could potentially be the result of methane fluorescence, a fascinating process where methane atoms absorb incoming light energy and then re-emit it at a different, usually longer, frequency. Alternatively, this intriguing glow could stem from the emissions of trihydrogen ions, exotic charged particles known to be abundant in the uppermost layers of Saturn's atmosphere. Or, perhaps most likely, it might even be a complex blend, a celestial cocktail, of both phenomena interacting in subtle ways. To definitively pinpoint the exact cause of this luminous edge, we will undoubtedly need to delve much deeper, conducting detailed spectroscopic studies that dissect the light into its constituent wavelengths, revealing the chemical fingerprints within. Yet, the mysteries surrounding Saturn's unusually dark appearance do not cease there. Intriguing, Curious patches have been observed in the planet's northern region, subtle patterns that are remarkably reminiscent of structures Webb had previously spotted on Jupiter just a few months prior. These enigmatic features could well be the footprints of gravity waves, ripples in the atmospheric fabric, dynamically interacting with aerosols present in the upper atmosphere. However, the precise mechanisms driving this process remain an intriguing enigma that scientists are actively working to unravel. But for now, let's shift our focus to the undisputed star attractions in these phenomenal images: Saturn's magnificent rings and its array of moons. Against Saturn's shadowy, almost ethereal backdrop, the icy rings unequivocally steal the show, radiating brilliantly and revealing their breathtaking, intricate splendor. They manifest as vibrant, astonishingly thick, horizontal bands, glowing with an otherworldly, snowy hue, effortlessly upstaging the muted, understated Saturn lurking quietly in the background. These majestic rings are composed of an unimaginably vast collection of ice and rock particles, varying dramatically in size from mere microscopic grains of sand to colossal, towering mountains. This myriad of icy debris reflects a significant amount of infrared light, creating the dazzling spectacle we observe. While Saturn's rings indisputably command attention and steal the show in this truly remarkable photograph, there's even more to this intricate cosmic tableau that draws our gaze. Making a discreet yet significant cameo appearance in this celestial snapshot are three of Saturn's astonishing 145 known moons: Dione, Enceladus, and Tethys. Appearing as luminous, delicate specks of light, they are neatly aligned one above the other in ascending order, a silent, cosmic procession. Among this trio, Enceladus stands out as arguably one of the most fascinating and compelling bodies in our entire solar system. Renowned for its dramatic geysers, which eject powerful sprays of its subsurface ocean over staggering distances, more than 6,000 miles or 9,600 kilometers, into the frigid vacuum of space, its allure has grown exponentially with the recent, groundbreaking discovery of phosphorus within these plumes. This icy world, with its hidden ocean and life-sustaining elements, now ranks exceptionally high among the most promising candidates for potentially hosting alien life beyond Earth, igniting our imaginations with the possibilities. You may naturally wonder, is this stunning image an exact, unaltered representation of precisely what Webb's sophisticated instruments saw? Interestingly, the answer is no, it isn't. The final, awe-inspiring picture is, in fact, the culmination of a meticulous process, the merging of several raw images captured by Webb, each utilizing different infrared wavelength filters. And that's not all. These images also undergo a crucial stage of post-processing, a complex series of adjustments and enhancements. In their initial, raw form, many of these captures presented Saturn as nothing more than a bright, almost featureless white blob with peculiar, protruding ears, a visual akin to shining an intensely bright halogen flashlight directly onto a reflective fabric, resulting in a blinding glare. Nevertheless, even within this rudimentary data, certain raw images caught the scientific eye more than others, offering invaluable insights. For instance, in one of the compelling raw images, we get a unique glimpse of Saturn as seen through most of Webb's NIR spec, near-infrared spectrograph, wavelengths. Here, with careful analysis, we can begin to discern Saturn's subtle cloud bands and witness the rings radiating around the central planet, mirroring the gentle, diffuse glow of a fluorescent ring light. This particular raw image also contains some inherent white specks, which represent cosmic noise or instrument artifacts. These were later meticulously edited out during the post-processing phase to refine and purify the final, scientifically robust picture. Another striking raw image, taken at very short near-infrared wavelengths, depicts Saturn as almost pitch black, a profound illustration of the immense methane absorption at those specific frequencies. All of this underscores the immense dedication, painstaking precision, and meticulous effort that went into producing the final, science-ready images that captivate and inform us. In summary, the composite image we ultimately see and admire as a result of the James Webb Space Telescope's observations isn't a simple, exact copy of its initial, raw captures. Instead, it is a sophisticated synthesis of various raw images, each acquired with different filters to capture distinct information, all of which have undergone subsequent, intricate processing. This culminates in an image that is not only scientifically enriching, providing a wealth of data for planetary research, but also visually enticing and deeply inspiring, bridging the gap between empirical observation and human wonder. Webb seized these stunning snapshots of the gas giant during a specifically focused 20-hour observational mission entirely dedicated to Saturn. This significant undertaking was meticulously designed around a scientific proposal seeking to leverage the invaluable NIR-SPEC data to delve even deeper into the enduring mysteries of Saturn's diverse moons and its magnificent ring system. It is also worth mentioning that the dedicated team spearheading this proposal specifically requested additional imagery of select Saturnian moons, coupled with supplementary observations using JWST's mid-infrared instrument, or MIRI, which offers different, complementary insights. As of now, these eagerly anticipated MIRI images and additional moon observations remain in the pipeline, and our collective astronomical gaze remains fixed on the horizon, eagerly awaiting the next revelations. However, even without the benefit of further dedicated imaging campaigns or unscheduled, serendipitous detections that might yet emerge, it is already abundantly clear that the James Webb Space Telescope's current, tantalizing observations are merely scratching the outermost layer of the monumental iceberg of knowledge awaiting discovery. These initial glimpses only begin to hint at the truly substantial revelations and paradigm-shifting insights that the telescope is poised to contribute to Saturn's ever-unfolding cosmic narrative in the years, perhaps even decades, to come. What deeper secrets lie hidden within the intricate dance of its rings, or the mysterious interactions of its icy moons, waiting to be unveiled by Webb's unparalleled infrared gaze? In a development that has sent ripples of excitement throughout the astronomical community, scientists recently announced a truly groundbreaking discovery, one that pushes the very boundaries of our understanding of the universe. With a mixture of awe and bewilderment, they pinpointed an utterly mysterious cosmic object, an enigmatic celestial entity that blazes with an astonishing intensity, shining an unbelievable 10 million times brighter than our familiar Sunday. Can you truly grasp the scale of that luminosity? Imagine a single, pinpoint source of light radiating with the collective power of countless stars, condensed into one baffling beacon that challenges our every assumption about extreme astrophysical phenomena. Consequently, a subsequent, meticulous analysis of this unparalleled cosmic powerhouse has not simply added another entry to the catalog of celestial wonders. Rather, it has served as a catalyst, propelling us into entirely new frontiers of theoretical understanding. This detailed examination has directly led to the formulation of new physics, forcing a re-evaluation of long-held models concerning everything from the mechanisms of stellar evolution to the behavior of matter under unimaginable energy densities, perhaps even hinting at novel particle interactions. If, by chance, you happen to miss the initial unfolding of this electrifying scientific saga, this isn't merely a discovery, it's a cosmic puzzle demanding new pieces. Then you absolutely owe it to yourself to delve into the fascinating details and catch up on this genuinely exciting and potentially revolutionary breakthrough.